By using triangles, it distributes the weight into the ground over here, and so it's not like when you pull down, this it sends the force up to here, and these vectors over here distribute the weight out over here, not down to the middle. Yeah. Yeah.
So it will not collapse. So basically we do depend on a truss system in our bridge, right? So we can redesign it whichever way we want, but we are using a truss system. Is there a relationship in your truss system between the total height and the length of the bridge?
No, there isn't.
No? So we can make it as long as we want and as high as we want. There's no relationship between those two?
No.
No?
We have requirements that we have to know.
But this right here has to be at least 1 foot in the scale.
Yeah, so
Like the lowest part of our bridge.
in real life,
Okay. I mean, I'm so surprised that you guys are not working with like real life numbers. Doesn't that confuse you?
No.
no, we just use the model number.
The amount, yeah.
Okay. Yeah, Nick?
We just have to build this thing.
The,
This is the material that we're going to use. And some material.
Which is okay. I think it's good for us to go through these exercises because then at least we understand what scale we're working at, you know? So we know then that we're working at 1 inch equals a foot, right? In relationship to the parameters that were set for you guys, right? So your car is about 9 inches. So shall we just assume that the scale we're working at is 1 inch equals a foot?
yeah, we already.
Yeah? Okay, so. Okay, so this being said, you're saying that the height of the first truss member has to be at least a foot?
Yeah. This section right here. Above the, see, this is the table, one table here, and in the middle, above the table has to be at least this little section right here is 1 foot high.
Okay, so how high is 1 foot? What?
So,
Basically
so it would be 12 feet.
the unit of the truss has to be 1 foot high.
So
In real life, it's
in real life it would be 12 feet.
Exactly, so in real life it will be 12 feet. Why is it important to know this? Well, so that we can actually get an idea aesthetically, right, of what's the relationship of a truss member to the actual size of a human being, right? Like, is it half the size of you? Is it taller than you? You know, can a person walk there or not, right?
Yeah.
So it's helpful for us to know that, right? So in a way, we know that in height, if we were to think of the truss system as a unit, the height of it would be 12 feet. Is there a limitation as to the width?
Well, it has to be. This has to be at least 4 feet.
No, but the truss itself.
There's no limitation.
No.
There's no limitation.
There's no
Well, I guess the table, but I guess the table, how tall the table is,
Okay.
wide the table.
Okay. So,
We probably want to make it as possible with writing
it will be stronger. So.
okay. So you guys are really thinking that your truss system stands from one corner to the other of the bridge, so you only have one?
Yeah.
That you only have one in each direction?
What do you mean? Like just one of these here?
Yes.
Instead of a cross?
Yeah, you're really thinking that this is the full width of your bridge, right?
Yeah.
Okay. All right.
I
And
mean, we could add stuff over here that don't actually support it, but that's
Okay.
the support.
so then that means that the width of the track is what? The width is 24 feet, so it's 12 feet by 24?
Yeah.
Yeah?
Yeah.
Okay.
So 2 feet in the scale.
So what other things do we need to know, guys? Yeah, Nick? It's a siteless project, so they don't know that. It's not located in a site yet, so we don't know about sun pollution.
What?
He was wondering if you guys had a site. If you did have a site, we would need to know that because it does change the aesthetic of the bridge a lot, where the sun rises and sets. But if you don't have a site, we don't have to worry about that. What are other questions that we might have? Okay, so it's 9 inches long. It's 9 feet long,
Maybe
6 feet
about
wide,
5 feet long.
5 feet tall. Yeah, I tried about 5 feet tall.
Well, I think that's what we're important. You're saying that drawing at the bottom of that, but it's just looking at it from like you're driving down the road.
Yeah.
Because then you're kind of closing off the
Guys, listen to Chris.
trust, right? Because you have all those cross members in there, but you have to make sure that you have clearance for your car. So one of those bays has to be open or has to be adjusted so that the car can fit through.
Did you guys get that?
Yeah.
So basically we have a problem here, right? Because the car cannot fit in this area right here, right?
Well,
so that's something that you guys are going to have to think about.
it's only gonna have to fit in this one. We're not gonna put a bar in this one. We're not gonna put a bar to that one.
So in this one you're not...
We're not gonna put a bar to that one. It's just gonna be an opening.
Okay. So,
We
this one...
also made a Google SketchUp model, so you can see that too.
Oh, you have it. That would be really helpful. Yeah, move the computer over.
It's not gonna help
You have a Google SketchUp model. That would have been really helpful to see at the very beginning.